Hello, today I'm going to be talking isotopes and how to find protons, neutrons, and electrons. Now in a few seconds, here's a summary. So first we're going to go over what isotopes are, then we're going to go over the steps that you can take to find the protons, neutrons, and electrons, and then I'll do some practice problems, and then I'll give you some problems to check your progress on this topic. If you're new here, my name is Liah, and on my channel you can find science and math videos. Now what are isotopes? Well, isotopes are basically when we are dealing with the same element, but different numbers of neutrons, or different mass numbers. So for example, here we have isotopes of carbon. So as you see, the 6 down here is going to stay the same because it's indicating the atomic number. But the 12, 13, and 14 are going to change because these are the mass numbers. Alright, and we know that the mass number is equal to the number of protons plus the number of neutrons. So essentially, whenever you change the number of neutrons and your proton number stays the same, it's always 6 for carbon, then you're going to get a different mass number. Now below that, we have isotopes for chlorine. Now this is another format that you might see isotopes written as, okay, with their element symbol, then a little dash, and then a number. So the number that is after the dash is the mass number. Okay, so I'll just write it larger here. And this is going to be the mass number. Now, in this case, no atomic number is given. No number of protons is listed. That is because you can always tell the number of protons by looking at the periodic table. Just look up chlorine, and you'll be able to tell that chlorine has 17 protons. So of course, if we say that the number of protons can be implied, then we can say that chlorine isotopes can be written as such, like this, okay, where we only show the mass number and the element symbol. And then you would have to do the work and say, okay, chlorine has 17 protons. Now, here we have another example, and these are the isotopes for strontium, Sr. So we have Sr86, Sr87, and Sr88. So again, all of these numbers are just the mass numbers for strontium, which tells us how many neutrons there are because we know that strontium is always going to have the same number of protons. It's going to have 38 protons. So essentially with isotopes, what you want to keep in mind is that if you change the number of protons, you're talking about a different element. In isotopes, we talk about the same element. So isotopes of chlorine are going to be chlorine atoms, but with different mass numbers or different numbers of neutrons. On the left here, I have listed the steps to find protons, neutrons, and electrons of isotopes. Now, in this example, the mass number is given, and we have no given atomic number. But looking at the periodic table, we know that chlorine has 17 protons. And so we can say that protons is equal to 17, and the mass number is equal to 37. Now, step 2 says to find the overall charge of the given element. And in this case, we know that chlorine, in this case, has a 0 charge. So we'll just say 0 is equal to the charge. And then for step 3, we see the number of neutrons is equal to the mass number minus the number of protons. So the mass number is 37. And if we subtract the number of protons, 17, we get our number of neutrons. And this is going to be 20 neutrons. And then finally, to find the number of electrons, you're going to do the protons minus the charge. So the number of protons is 17, and you're going to subtract the charge from it. So the charge is 0, so we'll just subtract 0. And this is going to get you your number of electrons. Now, it's important to note, as we saw in this case, that if you have a neutral or 0 charged atom, your number of protons is going to be the same as your number of electrons. That means in neutral species, you're going to have the same number of electrons as you do of protons. Now let's do this example. Let's find the protons, the neutrons, and the electrons for this isotope. So we have nitrogen 14 with a -3 charge. So we're going to get the protons from the periodic table, and that number is going to be 7. So nitrogen has 7 protons. The number of protons is going to be equal to 7. And then the mass number is going to be 14. Remember that number above? So mass number equal to 14. And then we have the overall charge of the element, which is -3. So we can say that charge is equal to -3. Next, we're going to find the number of neutrons. And we know that the number of neutrons, so I'll just put n for neutrons, is equal to the mass number. So what is our mass number? It's 14. And then we're going to subtract the number of protons, which is 7. And we know that 14 minus 7 is just going to be 7. So we know that we have 7 neutrons. Now to find the number of electrons, we'll put number of electrons is going to be equal to the protons minus the charge. So number of protons is 7, and we're going to subtract the -3 from it. Now subtracting a negative number is basically adding, right? So we'll just put a little plus sign here. So we know that 7 plus 3 is going to be 10 electrons. So in our answer, we can say that this is going to have 7 protons, 7 neutrons, and 10 electrons. Now let's do another example. See if you can find the protons, neutrons, and electrons for carbon-13. Feel free to pause the video for extra time. We're going to start off this problem by looking up carbon in the periodic table to see that it has 6 protons. That is its atomic number. So we have protons is equal to 6, and then the mass number is going to be equal to 13. All right, and then we're going to have the overall charge of the element. So in this case, carbon is neutral. There is no number here in the upper right corner. So the charge is 0. So what are we going to do next? Well, let's find the number of neutrons. So number of neutrons is going to be equal to the mass number minus number of protons. So that's going to be 13 minus 6. And that's going to be 7 neutrons. Now let's find the number of electrons. So the number of electrons is protons minus the charge. So we know that protons is 6 minus 0 charge. That's going to be 6 electrons, because 6 minus 0 is 6. So in the end, we know that the number of protons is 6, number of neutrons is 7, and the number of electrons is 6. Now let's do the same thing for this problem. See if you can find how many protons, neutrons, and electrons are in this isotope of iridium. The number of protons for iridium is 77. So its atomic number is equal to 77. Then we have the mass number, and that's going to be equal to 193. Next, iridium has a 0 charge. So we'll just say charge is equal to 0. Next, we're going to calculate the number of neutrons. So the number of neutrons is equal to the mass number, which is 193, minus the number of protons, which is 77. And this is going to be 116 neutrons. Next, for the number of electrons, we have 77 protons minus a 0 charge, which means we have 77 electrons. Right, so for this isotope of iridium, we have 77 protons, 116 neutrons, and 77 electrons. Now, what is the difference in the number of neutrons for the isotopes oxygen-16 and oxygen-18? Now, recall that mass number is simply equal to the number of protons plus the number of neutrons. So currently, for our first isotope, oxygen-16, we're saying that the mass number is equal to 16. And so this must be the number of oxygen protons, which is just going to be 8, plus the number of neutrons. And for our second isotope here, oxygen-18, we have a mass number of 18, and again, 8 protons, plus the number of some neutrons. Now all this is an algebra problem. We can just subtract 8 to each side for this one, and we'll get 8 neutrons. And then for this one down here, we do 18 minus 8, and we get 10 neutrons. So what is the difference in the number of neutrons between these two? Well, if you simply subtract these two, you get a difference of 2 neutrons. So what you can say is that oxygen-16 has 2 fewer neutrons than oxygen-18, and you can say that oxygen-18 has 2 more neutrons than oxygen-16. Now this was the long way. You can do this in a lot shorter way. You can just find the difference between the two mass numbers. You can just do 18 minus 16, and you will get a difference of 2 neutrons. Now it's time for you to check your progress with this topic. So what you're going to do is you're going to find the number of protons, neutrons, and electrons, and please feel free to write your answer in the comments. Thank you so much for watching, and I will see you next time.